So welcome. This is a video based upon polynomials. So the first question, consider the function. Find the value of a for the following functions when the graph is passing through 1, comma 10. It is passing through 1, comma 10. So plug in 1 and equates to 10. So f of 1 should be equals to 10. What does that becomes now? When f of 1 equals to 10, I get it out. A times 1 cube plus 2 times 1 square plus 3 times 1 plus 4 should be equals to 10. So it gives me a plus 2 plus 3 plus 4 equals to 10, which is nothing but what? Gives me a value equals to 1. Next, f of x is divisible by x minus 1. If at all it is divisible by x minus 1, f of 1 should be equals to 0. If it is divisible by x minus 1 means f of 1 should be equals to 0. So a times 1 cube plus 2 times 1 square plus 3 times 1 plus 4 should be equals to 0. This gives me a value as negative 9. F of x is divided by x minus 1. The remainder is 10. It is going to be the same one. So it is divided by x minus 1. The remainder is 10. So answer is f of 1 equals to 10. From here we get the value of a as 1. Confirm the result in C by using long division. So I have to do the long division to get the result in C. So let me add a page over here so that I can get that answer. So it was ax cube. A was 1, 1x cube plus 2x square plus 3x plus 4. Now I divide with x minus 1. So x times x square gives me x cube minus x square. Then it becomes negative plus 3x square plus 3x. Then it becomes plus 3x times. It becomes 3x square minus 3x. So it becomes 6x plus 4. Then it becomes plus 6 times 6x minus 6. So the remainder is 10. So we got that answer. Question number 2. Consider the cubic function. Find the values of a and b in each of the cases. If f of x is divisible by x minus 1, is divisible by x minus 1. It is divisible by x minus 1 means f of 1 should be equals to 0, which gives me a plus b plus 3 plus 4 should be equals to 0, which implies a plus b equals to negative 7. Remainder of 6 when divided by x minus 1. F of negative 1 equals to 6. It implies a times negative 1 whole cube plus b times negative 1 whole square plus 3 times negative 1 plus 4 should be equals to 6. So negative a plus b negative 3 plus 4 equals to 6. So negative a plus b equals to 5. So I got two equations. Solve these two equations. What are those two equations? A plus b equals to negative 7. Negative a plus b equals to 5. Add both. A and a gets cancels. 2b equals to negative 2. B equals to negative 1. So I got the value of b as negative 1. Now, once I get the value of b as negative 1, now plug in this one b in any one of the functions. So I plug in over here negative a, negative 1 equals to 5, negative a equals to 6. So a equals to negative 6. F of x is, for part b, f of x is divisible by x square minus 1. So x square minus 1 means nothing but what? X plus 1 times x minus 1. X plus 1 times x minus 1. It is divisible by x plus 1 times x minus 1. So what does that becomes? F of 1 should be equals to 0 and f of negative 1 also should be equals to 0. F of 1 equals to 0, just now we got that equation as a plus b equals to negative 7. F of minus 1 equals to 0. So this entire thing is minus 1. Minus a plus b plus 1 equals to 0. Minus a plus b plus 1 equals to 0. Now solve these two equations over here. So a plus b equals to -7, and -a plus b equals to -1. Then 2b equals to -8, b equals to -4. Plug in b as -4 over there. So you get a -4 equals to -7, a equals to -3. So the answer is a as -3, b as -4. Now, part C, f of x leaves a remainder -3x plus 3 when divided with x square plus 1. How should I be doing it out that? So, f of x when I divide with x square minus 1. So I get some other thing, q of x, but plus the remainder. What was the remainder? -3x plus 3. So the quotient may be q of x. So f of x equals to x square minus 1 times q of x plus the remainder -3x plus 3. Now we know that what this is for x equals to 1. If I plug in f x equals to 1, I am going to plug in x equals to 1. Then what do I be getting it out? F of 1 equals to 0 plus -3 plus 3, which is again f of 1 equals to 0. So what is f of 1? F of 1 is nothing but what? A plus b equals to -7. A plus b equals to -7. Next time what I will be trying it out? X equals to -1. Then f of -1 equals to, again it becomes 0, then plus 3 plus 3. So f of -1 equals to 6. Have we done f of -1 equals to 6? Yes, for that what we have done it out? Minus a plus b equals to 5. Minus a plus b equals to 5. Now from there we have already solved it out. So a equals to nothing but what? A equals to -6 and b equals to -1. Question number 3. Consider the cubic functions. Find the values of ABC if the graph of the function passes through the points 1, 0, -1, 2 and 0, 3. So plug in f of 1 equals to 0. So it implies 2 plus a plus b plus c equals to 0. It implies a plus b plus c equals to -2. Then f of -1 equals to 2. So you substitute -1, it becomes -2 plus a minus b plus c equals to 2. So it becomes a minus b plus c equals to 4. Then f of 0 equals to 3. It implies 0 plus a times 0 plus b times 0 plus c equals to 3. It implies c equals to 3. Now plug in c equals to 3 in the equations. So when I plug in c equals to 3 in the first equation, a plus b plus 3 equals to -2, a plus b equals to -5. Plug in c equals to 3, a minus b plus 3 equals to 4. So a minus b equals to 1. Now add these two equations. You get it out, 2a equals to -4. So a equals to -2. So plug in a equals to -2 in the first equation. So -2 plus b equals to -5. So b equals to -3. So I get the final answer as a is -2, b is -3, and c equals to 3 for the first part, part A. Part B also, he is passing through 3 points. So for part B, if the graph passes through 1, 0, -1, 0, and 3, 0, 1, 0. So f of 1 equals to 0. So what does that becomes? F of 1 equals to 0. Already we got a plus b plus c equals to -2. Next one is f of -1 equals to 0. So f of -1 is nothing but what? -2 plus a minus b minus 2 plus a minus b plus c equals to 0. It implies a minus b plus c equals to 2. Then f of 3 is also equals to 0. F of 3 equals to 0. So f of 3 equals to 0 means what does that becomes now? Plug in 3 over here. 3 cube is nothing but what? 27. 27 times 2, 2 times 3 cube plus a times 3 square plus b times 3 plus c equals to 0. So what do I get it out over here? 9a plus 3b plus c equals to minus 54. So I got these three equations. You can use the what is this graphing calculator to solve it out. Simultaneous equations: a equals to -6, b equals to -2, and c equals to 6. Use the GDC to calculate the values of a, b, and c. Question number 4. Consider the polynomial 4x cubed minus 4x squared minus 5x plus 3. Show that x equals to -1 is a root. So what am I going to do? F of -1. And I should be getting it out 0. 4 times of -1 whole cube minus 4 times of -1 whole square minus 5 times of -1 plus 3. So it is -4, then plus -4, +5, and 3. It is equals to 0. So therefore it is a divisible by, or it is a root. Find the other two roots. So for that, what am I doing it out? I should be dividing it. 4, -4, -5, 3. I know that -1 is a root. -1 start with 0. So it becomes 4. Add like this. Then -1 times 4. How much is -1 times 4? -4. So -4 becomes -8. Then again -1 times 8. It becomes +8. 8 minus 5 is 3. Then again -1 times 3 is -3. So -3 +3 becomes 0. So this was x cube. I am dividing with x. So this becomes x square, x, and a constant. So what does that can be written as? X plus 1 times 4x square minus 8x plus 3 equals to 0. This gives you x equals to -1 is one of the root. X equals to -1. Now we have to factorize this one. Directly I'm writing the factors. Factors for this one will be 2x minus 1 times 2x minus 3 equals to 0. So x equals to 1 upon 2, x equals to 3 upon 2. Find the other two roots by using long division. Done. Express the polynomial in the form of x minus a times bx minus c times dx minus e, where a, b, c, d, e belongs to z. X minus a times bx minus c times dx minus e. Now, just now we got this one as, that is only our answers over there. This was only our answer. X plus 1 times 2x minus 1 times 2x minus 3 is going to be a f of x. Question number 5. Complete the following table for each polynomial. Find the sum and the product of the roots, allowing non-real roots and repetition of roots, as well as the remainder when polynomial is divided by x minus 1. Sum of the roots. Every time sum of the roots will be the immediate two terms dividing by. So minus 6 upon 2, which is -3. Over here, I don't have x power 4, so 0 upon 2 minus 0 upon 2, which is 0. Over here, I have x power 9, so minus 1 upon minus 1, which is equals to 1. So let me write it out neatly over here. -1, negative of -1 upon 1, which is going to be 1. That's going to be the, what it says, sum of the roots. Coming to the product of the roots. Product of the roots will be the last constant term divided by the first coefficient. So, but you have to check it out whether it is a positive or negative. For that, if at all This is an even coefficient. The highest power is even. It is going to be last positive constant upon what is this? The highest coefficient. Highest coefficient. So over here it is 8 upon 2, which is 4. And if at all it is an odd number, in case of an odd number, it is going to be minus constant upon the highest coefficient. So it is minus 8 upon 2, which is negative 4. Now again, 10 is going to be an even number. When it is an even number, plus constant upon the highest coefficient. So the plus constant is nothing but what? Minus 1 upon 1, which is going to be minus 1. Reminder, when x divided by x minus 1, just plug in what is this 1 in the equation. So when I plug in 1 in the equation, I'm going to get 14. When I plug in 1 in the second equation also, I'm going to get 14. When I'm plugging 1 in the third equation, I'm going to get it out negative 1. Consider the cubic equation. Find the value of a if the sum of the roots in the cubic polynomial is 10. So sum of the roots will be immediate. Minus 2 upon a should be equals to 10, which gives me the value of a. What should be the value of a? Value of a equals to negative 1 upon 5. The value of a if the product of the roots is polynomial is 10. Now this is odd number, odd. If at all the highest coefficient is odd, what is the formula? Minus constant upon highest coefficient is going to be the product of the roots. Minus constant, what is the constant? 4. 4 upon the highest coefficient is nothing but what? A. So minus 4 upon a equals to 10. So this gives me the value of a as negative 2 upon 5. Question number 7. Consider the cubic function. Find the values of a and b given that the sum of the roots is 10 and the product of the roots is 12. Sum of the roots is minus b upon a equals to 10. Now this is again odd coefficient. So minus 4 upon a equals to 12. So a equals to, what am I going to get? A equals to negative 3. Plug in a equals to negative 3 over here. So b upon negative 1 upon 3 equals to 10. So 3b equals to 10. So b equals to 10 upon 3. Question number 8. The polynomial is divided by x minus 1. Find the value of a. So it is divided by x minus 1, is divisible by x minus 1, means f of 1 should be equals to 0. So what does that becomes? 1 minus 7 plus a minus 9 should be equals to 0, which gives me the value of a as 15. Then part B, give full factorization of f of 1. So what am I going to do? I'm doing the synthetic division. 1, negative 7, a is 15 and negative 9. I'm trying to divide with 1. 1, 0, 1, 1, negative 6, negative 6, 9, 9. So what does that becomes? X minus 1 times. This was x cube. I'm dividing with x. So this becomes x square x. X square minus 6x plus 9. So what does that becomes now? X minus 1 times x minus 3 whole square. Now part C. Solve the equation f of x is greater than, solve the inequalities. F of x is greater than 0. And so let us try to draw the graph. Without GDC, I'm trying to draw the graph. Now the roots are 1 and 3. Now I know that it is x minus 3 whole square. X minus 3 whole square means it bounces at x minus 3. So therefore approximate graph, what am I going to do it out is over here. I am going to do it out in this way. It bounces at 3. Why am I taking it out like that? How do I know it is in this shape? I'll try a random value 2. Plug in 2. So it becomes 2 minus 1 and 2 minus 3 whole square. It is positive. So the graph is positive. Therefore, that should be the shape of the graph. Otherwise, the shape of the graph can be in this way also, bouncing at 3. But the red color one is having f of 2 as negative. So therefore, the red color one is not possible. So only the Yellow color one which I have drawn, that's going to be the shape of the graph. Now what is he asking? Solving the inequalities. What are the inequalities? First one. So let me start writing over here. For the first part, f of x is greater than 0. F of x is greater than 0. When it is positive between 1 to 3 and greater than 3. So x lies between 1 to 3 or x greater than 3. Second one, he is asking us to find f of x is less than 0. When it is less than 0, if x is less than 1. Then part 3, f of x is greater than or equal to 0. F of x is greater than or equal to 0. So it is x greater than or equal to 3. Then f of x is less than or equals to 0. F of x is less than or equals to 0. It is less than or equals to 1 or at x equals to 3. Greater than or equal to 0 is f of x is greater than or equal to 3, or else x lies between 1 to 3 also. It is still positive. Question number 9. Consider the f of x equals to x cubed minus 2x squared minus 5x plus k. Find the value of k if x plus 2 is a factor. If x plus 2 is a factor, f of negative 2 should be equals to 0. So negative 2 whole cube minus 2 times negative 2 whole square minus 5 times negative 2 plus k should be equals to 0. This gives me the value of k as 6. Question number 10. When the function f of x is divided by x plus 1, the remainder is negative 20. So f of negative 1 equals to negative 20. So 6 minus 11 minus 22 minus a plus 6 equals to negative 20. So a equals to negative 1. When x power 4 plus ax plus 3 is divided by x minus 1, the remainder is 8. So f of 1 equals to 8. 1 plus a plus 3 equals to 8. So a equals to 4. The polynomial p of x is divisible by x minus 2. The remainder is 6. So f of 2 equals to 6 is divisible by x minus 2, means f of 2 should be equals to 0. And remainder 6 when divided by x minus 1. So f of minus 1 should be equals to 6. So f of 2 should be equals to 0. So it becomes 8 plus 4a minus 6 plus b should be equals to 0. So 4a plus b equals to negative 2. F of negative 1. So negative 1 plus a plus 3 plus b should be equals to 6. So a plus b equals to 4. Now solve these two simultaneous equations either by using the GDC or by direct formula. So I'm directly writing it out. It should be giving you a as negative 2 and b as 6. Factorize p of x completely. Now we know that it is divisible by x minus 2. So my quadratic or the cubic equation will become x cubed minus ax square minus 3x plus b minus 3x plus 6. So I do the synthetic division 1, negative 2, negative 3, 6, and I know that it is divisible by x minus 2. So plug in 2, start with 0, 1 plus 0 is 1, 2 times 1 is 2, 0, 2 times 0 is 0, negative 3, 2 times negative 3 is negative 6, so 0. This is x cube, so I am dividing with x, so it becomes x square, x and a constant. So it becomes x minus 2 times x square minus 9. So x square minus 3. So what am I going to factorize it out? It as x minus 2 times x plus root 3 times x minus root 3. So what are equals to 0? So what are the roots are going to be? Roots are going to be x equals to 2, comma root 3, comma minus root 3. These are going to be the roots. Question number 13. The polynomial p of x equals to ax plus b whole cube leaves a remainder minus 1 when divided by x plus 1 and remainder 27 when divided by f of 2 x minus 2. So p of negative 1 equals to negative 1. So plug in that one. So b minus a whole cube equals to negative 1. So b minus a equals to negative 1. Then a remainder of 27 when divided by x minus 2. So p of 2 equals to 27. So 2a plus b whole cube equals to 27. So 2a plus b equals to 3. Now find the values of a and b. You have two values. Either you can use a GDC or without GDC. So therefore solve it out. B minus a equals to negative 1. 2a plus b equals to 3. Now add subtract these two equations. Negative, negative, negative. So negative 3a equals to negative 4. So a equals to 4 upon 3. Plug in a equals to 4 upon 3 in the first equation equals to negative 1. So b, what does that becomes? B equals to 1 upon 3. Question number 14. The polynomial f of x equals to x cubed plus 3x squared plus ax plus b leaves a remainder when divided by x minus 2. Leave the same remainder when divided by x minus 2 and when divided by x plus 1. Find the value of a. So when divided by x minus 2 means f of 2 should be equals to f of negative 1. So it becomes 8 plus 12 plus 2a plus b should be equals to negative 1 plus 3 negative a and plus b. They should be same. So b and b gets cancels. So what am I going to get it out over here? 20 plus 2a equals to 2 minus a. So 3a equals to negative 18. So a equals to negative 6. So I got the value of a as negative 6. State the possible values of b. Now we can see that b is getting cancelled. So therefore, for any real values of b, any real values of b, because whatever will be the value of b, it is always getting cancelled. So a is negative 6 and any real values of b. Question number 15. Given that x minus 2 and x plus 2 are the factors, what does it mean factors? F of 2 should be equals to 0. So it becomes 8 plus 4p plus 2q plus 4 should be equals to 0. So it is 4p plus 2q equals to negative 12. So 2p plus q equals to negative 6. And f of negative 2 is also equals to 0. So it becomes negative 8 plus 4p minus 2q plus 4 equals to 0. 4p minus 2q equals to 4. 2p minus q equals to 2. Now solve these two equations. So add them both. So 2p minus q equals to 2. When I add it out, 4p equals to minus 4, which gives me p value as negative 1. Plug in p value as negative 1 in this equation. So negative 2, negative q equals to 2. So q equals to negative 4. Solve the equation f of x equals to 0. So now we come to know that x minus 2 and x plus 2 are the factors. So x minus 2 times x plus 2 times x plus a. It should be equals to x minus 2 times x plus 2 times x plus a. Now take the constants. Minus 2 times a should be equal to the constant 4. So negative 4a should be equals to 4. So a equals to negative 1. So therefore, what should be the equation now? It should be as x minus 2 times x plus 2 times x minus 1 should be equals to 0. So what are the roots? X equals to 2, x equals to negative 2, x equals to 1. These are the roots. Question number 16. The polynomial p of x is divisible by x minus 1 and x plus 3. Find the values of a and b. If it is divisible by x minus 1, f of 1 should be equals to 0. So, or P of 1, this is P, right? So P of 1 should be equals to 0. So it becomes 2 plus A minus 4 plus B equals to 0. So A plus B should be equals to 2. Then f of P of minus 3 also should be equals to 0. P of minus 3 also should be equals to 0. So when I plug in minus 3, so it becomes negative 54 plus 9A minus of minus plus 12 plus B should be equals to 0. So what do I get it out from there? 9A plus B equals to 42. So I got two equations, solve those two equations. So A plus B equals to 2, 9A plus B equals to 42. Then subtract these both. Negative 8A equals to negative 40, A equals to 5. Plug in A equals to 5 in the first equation. So 5 plus B equals to 2, B equals to negative 3. So what is the factorization now? It is x minus 1, x plus 3, and something x plus a. So take the constants. Minus 1 times 3 is minus 3. Minus 3 times a is minus 3a. Minus 3a should be equals to, what is the constant over here? B. What was b value? Minus 3. So what does that a becomes? A becomes 1. But over here, case should be taken that it should be 2x, because I want 2x cube. So 2x plus a. So my final answer is going to be, what is my final answer? X minus 1 times x plus 3 times 2x plus 1. Question number 17. The polynomial x square minus 4x plus 3 is a factor of x cube plus a minus 4x square plus 3 minus 4ax plus 3. Find the value of the constant a. So x square minus 4x plus 3, I can factorize it as x minus 3 times x minus 1. Now it is a factor. Once it is a factor, what can I do it out? F of 1 should be equals to 0. It implies 1 plus a minus 4 plus 3 minus 4a plus 3 should be equals to 0. This should be giving the value of a as 1. Factorize the polynomial completely. So once I get the value of a as 1. Once I could able to get the value of a as 1, so what am I going to get it out? X cube minus 3x square minus x plus 3 should be equals to x square minus 4x plus 3 times x plus b. So I take the constants. What are the constants? 3. And what is the constant over here? 3b. So what does that b will become? B equals to 1. So what is the factorization now? It becomes x square minus 4x plus 3 times x plus 1 is going to be the factors. Then find the remainder of the cubic when it is divided by x minus 2. So I am going to find it out f of 2. For part C, f of 2. Plug in 2. So what does that becomes now? 2 square minus 4 times 2 plus 3 times 2 plus 1. So which is going to give me negative 3. Over here we can still factorize this one as x minus 3 times x minus 1 times x plus 1. Question number 18. When p of x is divided by x minus 1, the remainder is minus 2. Find p of x. The remainder is minus 2. And when p of x is divided by 2x minus 1, the remainder is 13 upon 4. Find the values of p and q. So p of 1 equals to negative 2. So it becomes 4 times 1 cube plus p times 1 square plus q times 1 plus 1 equals to negative 2. So what does I get it out directly? Answer I'm writing P plus Q equals to -7. Next time when I plug in 1 upon 2, P of 1 upon 2 should be equals to 13 upon 4. So 4 times 1 upon 2 whole cube plus P times 1 upon 2 whole square plus Q times 1 upon 2 plus 1 should be equals to 13 upon 4. I am writing directly the equation over there. P plus 2Q equals to 7. Now solve these two equations. You should be getting P value as -21 and Q value as 14. Question number 19. When P of x is divided by x minus 1, 2x minus 1, the remainder is 17 minus 21x upon 2. Find the values of P and Q. So basically, P of x equals to x minus 1 times 2x minus 1 times some quotient plus 17 minus 21x upon 2. Now I am going to plug in 1, P of 1. P of 1, this entire thing will become 0. Then, and this will become minus 4 upon 2, which is, so P of 1 equals to nothing but what? -2. P of 1 equals to -2. So from there I get the equation 4 times 1 cube plus P times 1 square plus Q times 1 plus 1 equals to -2. So what do I get from there? P plus Q equals to -7. P plus Q equals to -7. That is one equation. I got it. Then, so I will write neatly over there. So what am I doing it out? I'm plugging 1. So once I plug in 1, so P of 1 should be equals to 0 minus plus minus 4 upon 2. So P of 1 should be equals to -2. So 4 times 1 cube plus P times 1 square plus Q times 1 plus 1 equals to -2. So which gives me P plus Q equals to -7. Next one, I am going to plug in P of 1 upon 2. P of 1 upon 2 should be giving me again 0 plus 13 upon 4. So P of 1 upon 2, plug in 1 upon 2, 4 times 1 upon 2 whole cube plus P times 1 upon 2 whole square plus Q times 1 upon 2 plus 1 should be equals to 13 upon 4. So it becomes 4 upon 8 plus P upon 4 plus Q upon 2 plus 1 equals to 13 upon 4. Multiply entire equation with 4. Before that 2 times 2, 2 times 4 and multiply the total with 4. So it becomes 2 plus P plus 2Q plus 4 equals to 13. So P plus 2Q equals to 7. So I got two equations. I'm trying to solve those two equations directly. I'll write that answer. So when you solve it out, you should be getting P equals to -21, Q equals to 14. Check that simultaneous equations. That's going to be the answer. Question number 20. F of x is divisible by x minus 1. Find the value of a. So f of 1 should be equals to 0. So when f of 1 equals to 0, what does that becomes? 1 minus 4 plus 3 plus a equals to 0. It implies a equals to 0. Then factorization. So 1, -4, 3, 1. I am dividing with 1. 0, 1 plus 0 is 1. 1 times 1 is 1. -3, 0. And a value was also 0. So 0, 0, so it's 0. So what does that becomes? Now this was x cube. When I'm dividing by x, it becomes x square. This becomes x. So what will be the factors now? Over there, x minus 1 times x square minus 3x. So x minus 1 times, take x common, x minus 3. That's going to be the answer. Solve the inequality f of x is less than or equals to 0. So when I try to draw the graph for this, I know the roots are 0, 1, 2 and 0, 1 and 3. Now when I plug in 2, I get a negative number. I plug in 2, I get a negative answer. So at 2 it is negative. So the only possibility is like this curve. This is a cubic curve, that should be the shape. Now he's asking it is less than or equals to 0. When it is less than or equals to 0, for x less than or equals to 0 or x lies between 1 to 3. This is going to be the answer. Question number 21. The polynomial is divided by x minus 1. Find the value of a is divisible by x minus 1. Means f of 1 should be equals to 0. So it becomes 1 minus 2 plus 1 plus a equals to 0. It implies a equals to 0. Factorize it out. So it becomes x cube minus 2x square plus x. This is f of x. So that becomes x common x square minus 2x plus 1. So it becomes x times x minus 1 whole square. Now solve the inequality. So therefore first draw the graph. What are the roots? 0 and 1. At 1 it bounces because it is whole square, it bounces. So now I want it is less than or equals to this one. So I think so it should be in this way, because when I plug in 0.5, when I plug in 0.5, I can see I'm getting a positive answer. 0.5 is over here, positive means this is going to be the graph. Now when it is less than 0, x less than or equals to 0 or x equals to 1. Question number 22. F of x is divided by x minus 1. The remainder is 3. So 1 f of 1 should be equals to 3. So 1 plus 1 plus 1 plus a equals to 3. It implies a should be equals to 0. So what will be the equation now? F of x equals to x cube plus x square plus x. Take x common, x square plus x plus 1. Now f of x is less than or equals to 0. So for that one, what should I be doing it on? F of x is less than or equals to 1, or x is a negative 1. So for which will be it will be negative 1? For x less than or equals to 1. That's going to be the answer for part C. So we can draw by drawing the graph, or else what it says by using GDC. X is less than or equals to 1. The inequality is, you can just check that as the x values are lesser than 1, it values will be keeping on becoming less than 0. Basically, we can use it as 0 will be the better case of doing it out. So that for all negative values of x, the function also becomes negative. Next, question number 23. The polynomial f of x is 2x cubed, 3x cubed minus a is divisible by x minus 1. So f of 1 should be equals to 0. So it implies 3 times 1 cube minus a should be equals to 0. It implies a equals to 3. Solve the inequality. So 3x cube minus 3 should be less than or equals to 0. So 3x cube is less than or equals to 3. X cube is less than or equals to 1. It implies x is less than or equals to 1. Question number 24. If alpha and beta be the non-real roots of the quadratic, write down the values of alpha plus beta. Sum of the roots is minus b upon a, which is minus 2. Product of the roots is c upon a, 6 upon 2, which is 3. Next, alpha square plus beta square. Alpha square plus beta square will be alpha plus beta whole square minus 2 alpha beta. So which is minus 2 whole square minus 2 times of 3. which is nothing but what? Negative 2. Then alpha minus beta whole square. Alpha minus beta whole square will be alpha square plus beta square minus 2 alpha beta. So just now we got it as negative 2 times of 3. So which is negative 8. If alpha and beta are the roots of this one, find a quadratic equation whose roots are alpha square beta plus alpha beta square. So first of all, alpha plus beta is negative 4 upon 2, which is negative 2. Alpha beta is 6 upon 2, which is 3. Now I want a new equation whose sum of the roots. Sum of the roots is alpha square beta plus alpha beta square. So I take alpha beta common, so it will become alpha plus beta. So which is 3 times of negative 2 minus 6. So I want a new equation whose sum of the roots is minus 6. Product of the roots is alpha square beta times alpha beta square. So which is alpha cube beta cube, which is alpha beta whole cube. So which is nothing but what? 3 cube, which is 27. So what will be the formula to find the equation? X square minus x times sum of the roots plus product of the roots equals to 0. So it becomes x square minus of minus 6 plus 6x. Then and product of the roots plus 27 equals to 0. But that's going to be the answer. Question number 26. Alpha, beta are the roots. Find alpha square plus beta square. So first of all, sum of the roots is minus b upon a, which is 2. Product of the roots is c upon a, which is 5. Then alpha square plus beta square. Alpha square plus beta square is nothing but what? Alpha plus beta whole square minus 2 alpha beta, which is 2 square minus 2 times of 5, which is equals to negative 6. Now find a quadratic integer whose roots are alpha by beta and beta by alpha. So first of all, I find sum of the roots. Sum of the roots is alpha upon beta plus beta upon alpha, which is alpha square plus beta square upon alpha beta. Alpha square plus beta square is minus 6. Alpha beta is 5. So sum of the roots is minus 6 upon 5. So what will be the product of the roots? Alpha upon beta times beta upon alpha, which is 1. So therefore, what will be the equation just now we learned? X square minus x times sum of the roots plus product of the roots equals to 0. So it becomes x square plus 6 upon 5x plus 1 equals to 0. That's going to be the answer. Or else you multiply by 5, 5x square plus 6x plus 5 equals to 0. Question number 27. The roots alpha and beta are the equation and such that alpha square plus beta square is 13. Find the real value of k, all the possible values of k. So sum of the roots. What is sum of the roots? Minus b upon a. Product of the roots, c upon a. Now alpha square plus beta square. Alpha square plus beta square is nothing but what? 13. But alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta equals to 13. So k square minus 2 of k plus 1 equals to 13. So k square minus 2k minus 2 minus 13 equals to 0. K square minus 2k minus 15 equals to 0. So k minus 5 times k plus 3 equals to 0. So k equals to 5 or k equals to negative 3. Question number 28. The polynomial is divisible by x square minus 3x plus 2. X square minus 3x plus 2. Sum of the roots is 7 and the product of the roots is 0. Find the values of a, b, c, d. So this is x minus 1 times x minus 2. Sum of the roots. Sum of the roots is minus a upon 1, which is equals to 7. It implies a equals to negative 7. Product of the roots. Now it is an even number. Even number means constant divided by a. So d divided by 1 equals to 0. So it implies d equals to 0. Now it is divisible by x minus 1, means f of 1 should be equals to 0. So 1 power 4 plus a times 1 cube plus b times 1 square plus c times 1 plus d should be equals to 0. So 1 minus 7 plus b plus c plus 0 equals to 0. So I get it out. B plus c equals to 6. And f of 2 is also equals to 0. F of 2 should also be equals to 0. So it becomes 2 power 4 plus a times 2 cube plus b times 2 square plus c times 2 plus d should be equals to 0. So 16 minus 56, because a is negative 7, b is 2b or 4b plus 2c, d is 0 equals to 0. So I get it out. 4b plus 2c equals to negative 40 or 40. So 2b plus c equals to 20. So I got two equations. B plus c equals to 6 and 2b plus c equals to 20. B plus c equals to 6 and 2b plus c equals to 20. Then subtract. Negative b equals to negative 14. So b equals to 14. Plug in b equals to 14 in the first equation. 14 plus c equals to 6. It implies c equals to negative 8. Factorize. Now, how do I factorize it out? I know already it is x minus 1 and x minus 2 and d is 0. So what is my equation will become x power 4 plus or minus 7x cube plus b is nothing but what? 14x and c is nothing but what? Negative 8x. So because d is 0, so take x common, so it becomes x cube minus 7x square plus 14x minus 8. And now x times, already we know two factors, x minus 1 times x minus 2. So another factor should be x plus a. Take the constants. Constant is negative 1 times negative 2 is positive 2. 2 times a is 2a. 2a should be equals to, over here, negative 8. So a equals to negative 4. Negative 4. So my final answer should be x times x minus 1 times x minus 2 times x minus 4. Question number 29. The polynomial f of x is given is divisible by x minus 1. The quotient of the division is the polynomial q of x. Find the sum of the roots, sum and product of the roots. Sum of the roots. Sum of the roots is minus b upon a, which is 2. Product of the roots, it is constant upon a, 3 upon 1, 3, because it is directly an even power. State the degree of q of x. Because it is degree 4, so I am dividing with 1 degree, so the degree will become decreased by 1, so degree will become 3. Find the sum of a and b. So we know that it is divisible by x minus 1, so f of 1 should be equals to 0. Plug in f of 1 equals to 0, so it implies 1 power 4 minus 2 times 1 cube plus a plus b plus 3 should be equals to 0, which gives me a plus b equals to negative 2. Coming to part D, the sum and product of the roots of q of x. So basically what is f of x? F of x is, because it is divisible by x minus 1, so x minus 1 times, it is x cube, because it was x power 4, so it is x cube minus cx square plus dx plus e. This is q of x. This is basically our q of x. Now I have to find the values of q of x. So what should I do? It is, so my q of x equals to x cube minus cx square plus dx plus e. Now sum of the roots for this one will be minus of minus c upon 1, which is c, and product of the roots is going to be nothing but what? It is odd function, so minus of e upon 1. Odd function means minus of the constant upon 1. That will be the sum of the roots and product of the roots of q of x. So the main intention is to find c and e. So product of the roots is negative e. Now how do I find it out? The value of c. Now this entire thing equals to x power 4 minus 2x cube plus ax square plus bx plus 3. So I move this one entire over here. So this should be equals to 2x cube minus x power 4 minus 2x cube. X power 4 minus 2x cube plus ax square plus bx plus c. Ax square plus bx plus 3. So what I will be doing it out? I will be comparing the coefficients of x cube. Coefficients of x cube. The coefficients of x cube is minus 2, and over here x times x cube and as x times x square and minus 1 times x cube. So minus 2 equals to negative 1x cube and negative cx cube. So negative c equals to negative 1. So c equals to 1. So therefore sum of the roots is going to be 1. What about the product of the roots? Now for that constant e. So what is that value over here? Constants, comparing the constants. Comparing the constants. What is the constant? Constant is 3, and over here the constant is minus 1 times e minus e. So e equals to negative 3. So what is the value of e? E is negative 3. So the product of the roots is negative of negative 3, which is 3. So sum of the roots is 1 and product of the roots is 3. Question number 30. F of x equals to ax power 4 plus bx cube plus cx square plus dx plus 16. Sum and product of both the roots is nothing but what? 8. Sum of the roots minus b upon a equals to 8. Product of the roots, it is even number, so therefore constant upon a. 16 upon a equals to 8. It implies a equals to 2. So negative b upon 2 equals to 8. So b equals to negative 16. Then f of x is divisible by x minus 1. So f of x equals to x minus 1 times q of x. F of x is divided by x plus 1. The remainder is 120. Is divisible by x minus 1. So f of 1 should be equals to 0. When f of 1 equals to 0, plug in that one. A times 1 power 4 plus b times 1 cube plus c times 1 square plus d times 1 plus 16 equals to 0. So what does that becomes? We know a is 2, b is 16, c we don't know, d plus 16 equals to 0. So c plus d equals to nothing but how much? Negative 2 is c plus d. Find the values of c and d. Then when divided by x plus 1, the remainder is 120. So f of negative 1 equals to 120. So plug in negative 1. So a times negative 1 whole power 4 plus b times negative 1 whole cube plus c times negative 1 whole square plus d times negative 1 plus 16 should be equals to 120. So a minus b plus c minus d plus 16 equals to 120. So this gives me c minus d equals to 86. So I got two equations. C plus d equals to negative 2 and c minus d equals to 86. Solve those two equations. 2c equals to 84. So c equals to 42. Plug in c equals to 42. 42 minus d equals to 86 implies d equals to negative 44. I got the values of c and d. Hence find the sum and product of the roots of q of x. So what is f of x first of all? Ax power 4 bx cube cx square dx plus 16. Ax to the power of 4 plus bx cube plus cx square plus dx plus 16, which is a value. A value was 2, b value was negative, and c value was 42, and d value was 44. X plus 16. This is nothing but what? It is divisible by x minus 1 times q of x. X minus 1 times basically 2x cube, then plus ax square plus bx plus c. Now this is q of x over here. So I will have to find it out the values of a and b. Now what am I going to do? Comparing the coefficients of x cube. So negative 16 equals to, how can I get x cube? X times x square minus 2 times 1. So negative 2 plus a. So a equals to negative 14. So, and I will be getting the constants. So what are the constants? 16 equals to negative c. So c equals to negative 16. So if my q of x is 2x cube minus 14x square plus bx minus 16, which is nothing but what? Q of x. So sum of the roots. Sum of the roots will be minus of minus 14 upon 2, which is 7. Product of the roots. Product of the roots will be, it is odd number, so minus of minus 16 upon 2, which is 8. Now question number 31. If alpha and beta are the roots of this equation, without finding alpha and beta, write down the values of alpha plus beta. Sum of the roots is 2 upon 5. Product of the roots is c upon a minus 4 upon 5. Part B, alpha square plus beta square. Alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta, which is 2 upon 5 whole square minus 2 times of minus 4 upon 5, which is 44 upon 25. Alpha cube plus beta cube, which is alpha plus beta whole cube minus 3 alpha beta times alpha plus beta. Plug in the values. Directly I'm writing the answer 128 upon 125. Find a quadratic with an integer coefficients 1 upon alpha and 1 upon beta. So first find sum of the roots. Sum of the roots is 1 upon alpha plus 1 upon beta, which is alpha plus beta by alpha beta, which is alpha plus beta is 2 upon 5, alpha beta is minus 4 upon 5, which is minus 1 upon 2. Product of the roots. 1 upon alpha times 1 upon beta, which is 1 upon minus 4 upon 5, which is minus 5 upon 4. So we learn that x square minus x times sum of the roots plus product of the roots equals to 0. So x square minus x times minus 1 upon 2 plus minus 5 upon 4 equals to 0. Multiply by 4, so you get 4x square plus 2x minus 5 equals to 0, whose roots are alpha square plus beta square and alpha cube plus beta cube. So for part D, sum of the roots is alpha square plus beta square, which we found it as 44 upon 25. Product of the roots is alpha square times beta square, which is alpha beta whole square, which is 16 upon 25. So what is the equation? X square minus x times sum of the roots plus product of the roots equals to 0. So it becomes 25x square minus 44x plus 16 equals to 0. Part E, alpha cube and beta cube. So sum of the roots will be alpha cube plus beta cube, which we found it as 128 upon 125. Product of the roots, which is alpha cube times beta cube, which is alpha beta whole cube, which is 64 upon 125. So the equation will be x square minus 128 upon 125 x square plus 64 upon 125 equals to 0. So 125 x square minus 128x plus 64 equals to 0. Question number 32. For the cubic function, the roots are r1, r2, r3. It is given that sum of the roots, two roots at a time, three roots at a time given. Alpha, beta, gamma are given. So what is alpha plus beta plus gamma? Alpha plus beta plus gamma. Find the value of alpha plus beta plus gamma, which is 5. And which is alpha beta plus beta alpha beta gamma plus alpha gamma equals to C upon A, which is nothing but what? -7. And alpha beta gamma equals to -3. What is being asked is asked as alpha square plus beta square plus gamma square, which is alpha plus beta plus gamma whole square minus 2 of alpha beta plus beta gamma plus alpha gamma. Simplify that, you should be able to get it out. 5 square minus 2 times of -7. So, which is 39. Then alpha square, alpha beta whole square plus beta gamma whole square plus alpha gamma whole square. Alpha beta whole square plus beta gamma whole square plus alpha gamma whole square is alpha beta plus beta alpha plus alpha gamma whole square minus 2 alpha beta gamma times alpha plus beta plus gamma. This is a formula. So this will become -7 whole square minus 2 times -3 times 5, which is going to be 79. A cubic polynomial who has the roots alpha square plus beta square plus gamma square. So sum of the roots for the new equation is alpha square plus beta square plus gamma square, which is 39. Taking two roots at a time, alpha square beta square plus beta square gamma square plus alpha square gamma square is 79. Taking three roots at a time will be alpha square times beta square times gamma square, which is alpha beta gamma whole square, which is 9. So the cubic will be x cube minus 39x square plus 79x minus 9 equals to 0. Coming to the last question. Consider the following cubic. Show that x equals to 1 cannot be the root of the quadratic. So if x equals to 1 is the root of this quadratic, 1 square plus 2 times 2 minus k times of 1 plus k square should be equals to 0. So k square minus k plus 3 equals to 0. But the discriminant for this one is nothing but what? -11, which is less than 0. So therefore, no roots. So it cannot be the root for that equation. Find the value of k in which of the following cases. If the polynomial has exactly one root. If the polynomial has exactly one root, delta should be equals to, first of all, we'll find delta, which is 2 minus k whole square minus 4k square, which becomes -3k square, -4k plus 4. Now, has exactly one root, two distinct roots, and three real roots. So, this should have exactly one root. If it should have exactly one root means my delta should be less than 0. So what does that becomes? For this, the critical values, if at all I do this one, 3k minus 2 times k plus 2. So k equals to 2 upon 3, k equals to -2. So delta should be less than 0. Means what is the condition? K is less than -2 and k is greater than 2 upon 3. Second one, it has two distinct roots. Means already one root is there from here, x minus 1. So one more root. So basically, in order to make you to understand in a proper way, let me do it out once again. It is being asked as one root, one real root. What was the question? The question was x minus 1 times x square plus 2 minus kx plus 2 minus kx plus k square. So already one root is this one. This is already one root. So this should have no root. No root. If this should have no root means delta should be less than 0. So delta is less than 0 means k is less than negative 2, k is greater than 2 upon 3. Now for part 2, two roots. What does it mean, two roots? X minus 1 times x square plus 2 minus k times x plus k square equals to 0. Two roots. One root is already over here. So this part should have one root. This part should have one root means delta should be equals to 0. So k equals to negative 2, k equals to 2 upon 3. Now part 3. Three roots. Three roots. So again x minus 1 times x square plus 2 minus k times x plus k square equals to 0. Already this has one root. So this should have two roots. So delta should be greater than 0. So k lies between negative 2 and 2 upon 3. That's going to be the answer. Part C. Find the roots of f of x for each value of k in case of b2. b2. So what was our b2? K equals to negative 2. If k equals to negative 2, the quadratic will become x square plus 4x plus 4, which is x plus 2 whole square. So the roots will be x equals to 1 and x equals to negative 2. Next value of k is 2 upon 3. So quadratic will become x square plus 4 upon 3x plus 4 upon 9. So which is x plus 2 upon 3 whole square. So what will be the roots? X equals to 1, x equals to negative 2 upon 3. That's going to be the answer. That completes this video. See you in the next video. Bye.